All right, this is our first video in our unit on quadratic functions, and in this particular video we will be graphing some simple quadratic functions where the b coefficient is equal to 0. I'll explain what that means in a second. And we'll start with an introduction and then go through a few solved examples. So what I mean when I say b is equal to 0 is we are going to be working with standard form here. Not always, but today we will be. And this b value, the coefficient that x is being multiplied, will be 0. Okay, so there's not going to be that middle term there, today at least. So today we will be looking at equations that have this form. And we will be manipulating A and manipulating C, and then seeing how those affect the graph and graphing them up. First, though, what I want to do is graph what we call the parent quadratic function, which is the most fundamental parabola. Parabolas are what we call the graphs of quadratic functions. And so this function is y equals x squared. And I'm going to take you through making a table and then plotting those points and sketching the curve to do that. So let's just plot a basic set of points where x goes from -3 to 3. And then we'll square each of those values. Keep in mind that -3 squared is not -9, it's a positive 9. So when we square a negative number, we will get a positive number. And we have some symmetry on both sides. Just to be clear about what I was just saying, we are squaring -3 to get a 9. We are not doing this, which would be a -9. Okay, in this example right here, we square the 3 first and then make it negative, so we would get a -9. But what we're doing today is we're squaring the entirety of the negative number to get a positive number. Okay, so this is really the way to think about the work we're doing today. So let's plot those points. Okay, so we can set up a scale. I'll go by, whoops, let's not erase that axis. I'll go by 1s here, and let's go by 1s here, see how far we get. So let's have every 2 squares be a 1. And let's plot things up. So here's -1, 2, here's -3. And let's see, we probably won't be able to fit 9 based on our scale. So let's actually change the scale. Let's go up by 1s, 2s, 3s, like that. Okay, so keep our x-axis the same, but we just compress the y-scale a little bit. So let's go up by 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. The nice thing about parabolas, especially this one, look for some symmetry, and you'll be able to see some symmetry right away. And we know that both -3 and 3 reach 9. Okay. -2 and 2 both go up to 4. -1 and 1 both go up to 1. And 0 is at 0. Okay, so there's our parabola. Right now it looks like we could just have straight lines, like an absolute value function on either side. But if you look at it carefully, it is curved. And I'll try to sketch in a smooth curve. This is often one of the hardest parts, to try to just sketch in a nice, smooth curve. So really try to be careful with that. And it looks like I plotted this point wrong. I missed the 3 there. Okay, so there's a pretty good looking parabola right there. Okay, so a couple things to notice. A parabola has a vertex. So this vertex is right here. A parabola has an axis of symmetry, and the axis of symmetry on this one is the same as the y-axis. And we also talk about if a parabola opens upward or opens downward. So in this example, it opens upward. You can call it a smile. If it opens downward, it looks like a rainbow. Okay, so those are just a couple things we talk about. In some more complex parabolas that we'll look at in a second, we can talk about x-intercepts and y-intercepts as well. But we only have one x-intercept and one y-intercept here, and that's the origin. It's the same as the vertex, so that might confuse things a little bit. All right, so let's go through some examples. So every parabola we'll be looking at in this entire class is a modified version of what we just graphed. It might be stretched or compressed or flipped or translated, moved in one direction, up, down, left, or right. So every parabola is just a modified version of that core parent parabola we just did. So let's graph some things up. So I'll do my same set of x values, and to choose those x values, that's sort of my standard set that I start with. But when you're plotting points, if you're seeing that you don't get a parabolic shape, maybe you're just getting 1/2 of the parabola because the parabola has been shifted to the side. Just make sure you're capturing the shape of the parabola and the points that you plot. So you might have to choose some more x values. So here we're going to square things and then multiply by 3. So this will turn into a 27, and using symmetry, that'll be the same as well. This will turn into a 12, which is -2 squared is 4, and then times 3 is 12. These guys turn into 3's, and then we have a 0. So you might see something interesting here. I'm going to need to adjust my scale so that I can reach 27. And to do so, it's going to make the parabola appear perhaps the same as the one we just graphed. But what I think you need to pay attention to is what the scale is, so you can really tell what the shape of the parabola is. So we could still go out by a scale like that. And we have to get up to about 30. So let's do 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's have maybe go up by 4s. 8, 12, 16, 20, 24, 28, 32. Okay, that'll roughly get it. Probably could have gone up by 3's, but that's okay. And so -3 up to 27 is going to be about right there. And then using symmetry, -2 up to 12 is exactly right there. And then -1 up to 3. And then 0, 0. Okay? So I don't want you thinking that this parabola has exactly the same shape as the one we just did, just because it looks like the same shape. Let's go back and compare. It looks very, very similar, right? I'm going to quickly go over to Desmos just to convince you that the parabola we just graphed is much skinnier. Okay? So let's do our parent parabola, y equals x squared, and let's do the one we just graphed, y equals 3x squared. So here you can see the blue parabola has been stretched vertically and has been narrowed, right? So the blue parabola, our modified parabola, is much skinnier. Let's go back and keep going. Vertical compression is just going to do the opposite thing and is going to compress it vertically. So -3 squared is 9 times 0.25 is 2 1/4, 2.25, and same thing for 3. 4 times 1/4 is 1, and this is 0.25 and 0. So setting up our scale, we can have our scale really go up 1, 2, 3, 4. I'm going to go up by 1s right here. Actually, let me do this. Let me have just a normal 1-by-1 scale so you can really see how things have been compressed. So over -3, 3 up 2.25. Over -2 up 1. Over 1 up 1/4. And 0, 0. Okay, so this is a very much flattened parabola, vertically compressed parabola, and just real quick over here, x squared, you can see the green parabola has just been flattened quite a bit. Okay, vertically compressed. We can also do a vertical reflection, and that let's see here, we got a couple more. Okay, we can do a vertical reflection just multiplying by -2. So same deal, -2, -1, 0, 1, 2, 3. So this is going to be a -18, a -8. We're squaring it and then multiplying by -2. Okay, let's go by ones and let's go by ones here. So -3 and down 18, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's change our scale. Let's have this be 2. 1, 2, 3, 2, 4, 6, 8, 10, 12, 14, 16, 18. And same for +3. -2 goes down 8, 2, 4, 6, 8. Ones go down 2, and then we have the 0, 0. Okay, so again, a flipped parabola because we multiplied by a negative, so this one opens downward, and it's been vertically stretched as well. That's called a vertical reflection. And lastly, let's just shift things down. And on this one, I will again address quickly the idea of what x and y intercepts are. So I'm just going to go by ones here, and I think I can commit to that on this one. So -3 squared is 9, -3 is 6. So we'll have some symmetry. -2 squared is 4, -3 is 1. 1 minus 3 is -2, and this is -3. Okay, so -3 and up 6. 1, 2, 3, 4, 5, 6. And we have symmetry. -2 up 1. -1 is down 2. And then 0, 0 is at down, the vertex is at -3 on the y-axis. All right, so just a quick reminder there. This is the vertex, and I use that notation v and then its coordinate. This is also the y-intercept, and then we have 2 x-intercepts. All right, so just some attributes of the parabola right there, and that's a good place to stop.